we're going to look at our success criteria. So what we are supposed to be doing is integrating basic indefinite integrals, okay? And we're supposed to be integrating trig functions, and you want to see my screen, right? All right, that's what I'm going to do, right? Okay. Okay. It should be shooting out to you. All right, so we had mixed both of those things together, so we've seen both of them. Today we're going to work on ones that have a little bit more algebra probably that we have to do first, or a little bit of trig that we have to do first before we're going to do the calculus on it, okay? So, and these ones here, where were they at? These three here were mislabeled. They're not pancakes. Those are eggs, okay? So if you want to change it, I don't know what happened, so, but those ones should have been egg problems. So I would rate those ones as eggs when we go to look at it on the on the quiz. These three here are egg problems, right? Because we're saying that those are the ones with the trig, and they work slightly differently than the ones with the polynomials. Okay. All right. So we are looking at number 14. Okay. I am going to try to simplify that before I integrate it. Okay. So I am going to use some of my basic trig identities. Okay. You are expected to know those, sine over cosine, and what the reciprocal identities are. Sometimes you'll see a Pythagorean theorem, but it's rare. Or Pythagorean identity, but it's rare, okay? Doesn't mean it's not fair game. It totally exists, okay? All right. The first time I taught calculus, I still remember it. The band director from, Rancho, his daughter was in my class that year. And I still remember it because I didn't teach I didn't teach the Algebra 2 trig. I didn't teach the trig class, so it'd been a long time since I reviewed trig. And all of a sudden, we hit one of the trig identities, and I didn't remember it. So clear of a moment. She's like, oh, it's one of these things. Hey, what's up?
Got a minute?
Can you come back in about 15, 20?
Sure.
Yeah, then I have a minute.
I got something to show you that's going to help you out.
Okay, sounds great. Thanks. All right. All right, so let's split this up. So we've got sine x, okay, over, and I'm going to split it into cosine x. And then, actually, I'm going to do this the other way. I'm going to set us up for a little bit better success. I'm going to go 1 over cosine x and sine x over cosine x dx. All right. 1 over cosine x. What is that reciprocal? Secant x, good. Okay. And then what's sine x over cosine x? Tangent of x dx. Okay, that should look familiar now, right? So what's secant x tangent x? It's secant, right? Secant x plus what at the end? C. So I had to do a little trig identity business, right? And then I had to do the plus, and then I had to integrate it, okay? If I had set it up and it said tangent x, secant x, isn't that the same thing, right? It's just you have to recognize it's in the right order, okay? Or in the opposite order than what we're used to, okay? All right. Let's look at 15 together, okay? I don't see anything yet on 15, okay? But what's instinct kick in and tell us to do with these guys? Distribute. So if I don't see anything yet that integrates perfectly yet, and was one of the ones that we were supposed to memorize, right? I'm going to do a little bit of algebra. So what's secant times tangent? Secant tangent. So secant y, tangent y. I'm going to use that in minus sign. So it's secant y times secant y is secant squared y, and then we keep the dy at the end. Technically, there's supposed to be parentheses around that whole thing. All right. What's secant y, tangent y? Secant, okay, y, and then I'm going to put a minus sign. What's the integral of secant squared? You can look at the list, it's okay. What do we see? Tangent of y, and then what goes at the end? Plus c. Okay, so between now and Friday, okay, you need to make sure you have those basic integrals memorized, okay? It wouldn't hurt to take that little list of the trig ones, and not the ones that are the natural log ones. I'm not putting those on, right? But those other 6, write them 5 times each, right? For the next 3 days, write them 5 times each, okay? After class today, go into the library or wherever you go and hang out before first period. Go write them 5 times, okay? Get used to them, all right? All right, this one here is the one I said it's probably not going to be, okay? But it is technically fair game. All right, I see something with squareds in it, right? I'm going to look up at my pink Pythagorean sign. What does that turn into? I know it's been a while since we've that sign. It's sine squared, right? It's the first row, third column. So cosine 1 minus cosine squared is equivalent to sine squared x dx. All right. This one is almost identical to the one above it, right? So now that we've got it in this format, it's almost that. Okay? So I'm going to give you a minute. See if you can separate it. Use the same model that we did on 14. Okay? Okay, let's check it. So what can I split this into? 1 over sine x times cosine x over what? Over sine x. Good. All right. What's 1 over sine x equal to? Cosecant x. Good. Oh, thank you. Cosecant x. And then what's cosine over sine equal to? Cotangent x dx. Okay. And then when I integrate cosecant, cotangent, what do I get to? Plus. See, remember, if we don't put the plus c's, I'm taking a point off on every problem. You don't want that to happen, right? That takes your 4 to a 3. Okay. All right, any questions on the trig ones? All right. These are kind of more of the same, all right? We're going to practice with a little bit more algebra in it, okay? So let's do this one that's going to have some fractional exponents. So I am integrating. We've got 3x to the what power? 2/3 minus 4x to the what? 4/3 plus 2x to the what? 3/2 dx. Okay, we're going to add our fancy 1, right? What's my fancy 1 going to look like in the first term? 3. It's going to be 3 over 3 in this one and 2 over 2 in the last one, right? Okay. We're adding the 1 and dividing by the new exponent. I'm going to leave myself a little bit of space for the extra coefficient, okay? So I get x to the what power? 5/3 divided by 5/3 or multiplied by 3/5. Good. Minus 4, leaving space for the extra coefficient. Because I know it's coming, right? I'm planning ahead. What's 4/3 plus 3/3? 7/3 divided by 7/3 or multiplied by what? 3 over 7. Good. Plus 2x to the, what's 3/2 plus 2/2? 5/2 divided by 5/2 or multiplied by 2/5. I was going for a parentheses. I'm going to do a dot. 2/5. And then plus what at the end? Plus c. All you got to do is clean up the multiplication, right? Make that a better dot. All right, so it's 3 times 3. So 9/5 x to the 5/3. 4 times 3. 12/7 x to the 7/3. 2 times 2. 4/5 x to the 5/2 plus c. All right, any questions on that one? All right, let's take a look at example 18, okay? I'm going to start it with you and you're going to finish it for me, okay? I can't do it in the format that it's in, right? What do I have to do with all of these first? Move them up how? Make what negative? The exponent. So I'm going to go 2x to the negative 5 plus 3x to the negative 4 minus 6x to the negative 2 dx. Remember, we are adding 1, right? It's going to change it a little bit differently than it does when we do this with a positive, okay? So I want you to do your add ones, okay, and divide by the new exponent. I want you to move all your variables back downstairs, okay? So I'm going to give you a minute to try to do those 2 lines. Okay, so everybody try it. Give you about 15-20 seconds. Get as far as you can. All right, let's check it. So we've got 2x to the what power? Negative divided by negative 4. Good. I'm going to erase my line there. Plus 3x to the what? Negative 3 divided by negative 3 minus 6x to the negative 1 divided by negative 1 plus what? C. I gotta do some signs right there, right? Can I reduce the 2 into the 4? How many times? Twice. Okay, so then at the same time, I'm going to float the negative in front, leave a 1 on top, bring my x to the 4th downstairs. That's a lot in one move. Okay? What happens with the 3's? Cancel. I'm left with I'm putting a negative for the negative, 1 in the numerator, x cubed in the denominator. Okay? This time the 6 stays upstairs, right? It's positive, and then the variable comes downstairs with an exponent of 1 plus c. Do not try to put it together beyond that. I'm not looking for you to make a common denominator here, okay? So don't let the algebra mess you up from there, all right? Just leave it the way it is, okay? Any questions on that one? All right. 19 and 20 are basically the same problem, okay? Let's do 20 instead of 19, because 20 has a little bit more to it, okay? We'll let it's Wednesday, right? Short class period, so. All right. When I see something like this, I need to split it into 3 fractions, or 4 fractions this time. It's very similar to, we did one yesterday, I think. That one right there, example 12. How we split that up into 2 fractions. Same thing here. We're going to split it up into multiple fractions with the same denominator. So we're going to do 3x to the 4th divided by x squared minus x cubed over x squared plus 5x squared over x squared minus 3 over x squared dx. I'm still going to do a little bit more algebra before calculus. Okay? So I'm going to simplify my exponents, my monomials, right? I'm doing those exponent properties we learned last year, okay? So what happens when I am dividing with my exponents? Subtract. Okay, so we've got 3x to the what power? Squared. Good. Minus x. Good. What happens with these x's? They just cancel out, so I get plus 5, and that's okay. All right, and then this one here, I don't like it in the denominator to integrate. What do I have to do? Okay, move it up, and I heard what with the exponent? Make the exponent negative. All right, from there, I want you to do the calculus. Okay, there's a little bit of everything in that one. A little bit of everything we learned. The only thing that's missing is a fraction and some trig. All right, let's check it. So we've got 3x to the what? Third over. Good. Minus x squared over. Good. Plus. Good. Minus 3x to the negative 1. Because right, we're adding 1 divided by plus c. Okay, I wrote way too big. All right, my 3's cancel, so I get x cubed minus x squared over 2 plus 5x. That's going to go positive, so 3 over x plus c. Any questions? All right, let's take a look at 21. 21 is a good algebra review. I don't know that we need to do any more of the calculus on it, but it's good for the algebra because it's been a while since we've done something like this. We do have quantile coming up again in January. The juniors have S back in April, so it's good sometimes to see some of this extra algebra that we haven't seen in a while, okay? Whenever we see squared, what's Mrs. Ballard's rule? Write it twice. So that means we are doing x squared minus x plus 2 times x squared minus x plus 2 dx. Before, and remember, I don't have a product rule, right? This is integration. There isn't a product rule. Before I can actually integrate that, I need to multiply that out. So y'all remember the box? Not just the 2 by 2 box, but a 3 by 3 box. So we've got to go x squared minus x plus 2 and x squared minus x plus 2. And all the box does is help keep my work organized, right? So I do not miss a term. Okay, it's a good tool. All right, what's x squared times x squared? Good. X squared times negative x. Good. X squared times 2. Negative x times x squared. Good. Negative x times negative x. Do we agree with negative x squared, guys? Positive times positive should be negative, or negative times negative should be negative, right? Or sorry, positive. Oh my gosh, I messed it up too. All right, negative x times 2. 2 times x squared. 2 times negative x. And 2 times 2. 4. And 95% of the time, my diagonals are the like terms, right? So let's combine our like terms here. We get x to the 4th. What's negative x cubed and negative x cubed? Good. What's 2x squared, x squared, and 2x squared? Negative 2 and negative 2x. Good. And then plus 4 dx. All right. Practice one more time. You integrate it on your own. You do the calculus piece. All right, let's check it. So x to the what? 5th over 5 minus 2x to the 4th over plus 5x to the over minus 4x to the over plus see, the only thing we could simplify is this one right here, right? So minus, oh no, I take that back. This one can simplify too, right? So it is x to the 4th over 2 plus 5x cubed over 3 minus 2x squared plus 4x plus c. Okay, any questions? All right, we can handle this stuff, you guys. Remember, you always look for that algebra before you do the calculus piece, okay? I'm going to put some of the harder ones on it. I don't want to just see you doing the simple, okay? So I highly recommend we work on some homework, okay? It's only 8:02 and you have till 8:11, so let's find the homework assignment. I think I put